Hey gang, this is a little helper video if you're having troubles with Wednesday, April 1st. So numbers 1 and 2, all they want you to do is simplify the expression. So the only simplifying you can do here is combining like terms, and you can only combine terms that are alike. Okay, now I guess the only plot twist to worry about, just to begin with, is whether or not there's bubbles or parentheses to kind of clear first. So in this random example here, you would first distribute the 2, and here you would distribute. Now here's the rest of the plot twist, I guess. Here you gotta realize, this is where, like, I think a lot of us were getting tripped up, way back when. We're distributing a negative 4. Okay, not just 4, we're distributing a negative 4. And so whereas this would just be 2 times x squared plus 2 times 3x, that's 6x. Here we're distributing a negative 4, so negative 4 times x squared is just negative 4x squared. And then negative 4 times negative x, well, that's going to be positive 4x. And then these other terms would just drop down for now. And then just remember that like terms are terms that have the same variable with the same exponent. So like this term and this term are not combinable. They're not like terms. But the 2x squared and the negative 4x squared, remember, there's another big thing. The sign in front of the term is a part of the term. So this is a positive 6x. This is a positive 2x squared. This is a negative x squared, or to be a little more thorough, a negative 1x squared. This is a positive 3x. Anyway, back to it. So a 2x squared, a negative 4x squared, and a negative 1x squared. They're all x squared terms. And so 2x squared minus 4x squared, well, so far that's negative 2x squared, and then minus 1, so it'd be like negative 3x squared. And then these terms are alike. Positive 6x, positive 4x, that makes 10x so far. And then plus 3x would be plus 13x. Okay? Now 3, 4, 5, and 6 on your assignment talks a lot about slope. So just a reminder in case you got stuck or you couldn't remember some key things. 2 lines that are perpendicular to each other, okay, there's a certain way those slopes compare to each other. Just like if 2 lines were parallel, okay, there's a certain relationship. So if they mention parallel, that means like exactly the same slope, because the slope of this line is going to be exactly the same as this line. So for example, if you have like you want to find the slope of a line that's parallel to, say, I don't know, 4x plus 3y equals 9, I guess, I don't know. You would need to figure out the slope of the line for this equation, because whatever the slope of this line is, like, you're going to say that exact same slope for parallel. Now, you're not going to know what the slope of this line is until you put it into slope-intercept form. In other words, solve for y. Start by subtracting the 4x to to the other side. And so that leaves 3y over here on the left. Now 9 minus 4x, those don't combine. Like we just got done up here talking about like terms. You can't do 9 minus 4x. They're not alike. So you're just going to leave these two terms separate, and it's better if you put the x term first, because then it literally matches the form of y equals mx plus b. The mx comes before the b. So what do we have? 9. And then you would divide both sides by 3 to finish getting this in slope-intercept form, y by itself. And so you're going to be dividing both of these terms by 3. You know what I mean? Now, obviously, we're going to care much more about just what we're going to get here, because all this question wants in number 3 or number 4, number 4, is the slope. So negative 4 divided by 3, if that divided cleanly, we would divide it cleanly. But it doesn't, and it doesn't even reduce, so it kind of remains the fraction. Got to be a fraction. Well, it doesn't have to be, but it should be. Negative 4 over 3. Okay, so the slope of this equation is negative 4 over 3, and if they want what's parallel, the slope of a line parallel, we would go with that exact same slope. Now perpendicular, these lines would compare to each other in this way. The slopes would be, first of all, opposite signs, so one's positive, one's negative, and they would also be reciprocals of each other, or as I say, reflipricals. So if they want the slope that's like perpendicular to some other line, you take that other slope and you change the sign and you flip it. Okay? Now 5 and 6, numbers 5 and 6, try to remember that these special looking equations are special types of lines. Okay? Now you might remember me in class once upon a time telling you about the memory trick Hooyvuks. Alright? So this kind of summarizes what the slopes are and what the equations kind of look like for horizontal lines. H stands for horizontal. And vertical lines. So the V here stands for vertical. So if a line is horizontal, okay, its equation will only have y, like y equals negative 8 or y equals positive 2. You know what I mean? That's what the y here is for. And this O is actually a 0, which means the slope of a horizontal line would be 0. And if a line is vertical, then its equation will only have an x in it, like x equals negative 1 or something. And its slope will be undefined. So this U here stands for undefined. Another way to say undefined slope is to say that it has no slope at all, or that its slope does not even exist. Okay? Now, the systems of equations in numbers 7 and 8. Alright, just kind of remember that. Oh, I wish more of this was done in advance on my active board, which I'm not around right now. But the substitution method, if one of the equations is already solved for x, or in this case it's already solved for y, that's what step 0 is all about. Make sure one of the equations is already solved for a variable. Bingo, y equals 2x minus 7. So then you could substitute that equation into the other one. So here, you would get yourself going by plugging in this entire 2x minus 7 in for y in the other equation, because y literally equals 2x minus 7. So you would say that this equation is now written as 4x plus 3 times y, which we're saying is 2x minus 7, and then bring down the rest of it, equals 4. So now you have an equation you can actually get somewhere with, and you can distribute the 3 and just pretty much keep this going and solve for x. So solve that for x, or whatever your variable is that you have. And then once you know what x is, you can plug that into one of these equations and figure out what the other variable is, in this case y. Now if you were doing the other method, okay, the elimination method, that involves adding equations together, but you need one of the variables to drop out for a second, okay? So you're not going to actually add the equations together unless there's opposites with the x's or the y's, or whatever your variables are. So in this example, you already have opposites with the y's, so you could go ahead and like add, well, first of all, make sure everything's lined up. You can't actually add the equations together properly unless the x's are lined up and the y's are lined up and the equal signs are lined up and the number constants are lined up. So like I've already said, make sure there's a pair of opposites. Now in this system there already is, so fantastic. So you would add these equations together. So you would add the x's together and get 5x. These cancel out. And that's the idea. And over here, so the equal sign comes down, and then 7 plus 3 is 10. And now you have a super easy equation, or super quick equation anyway, to solve for x. And so x would equal 2 here. Okay? And then just like always with these systems, once you know what x is, or once you know what one of the variables is, you can plug that into one of the equations and solve for the other variable. So here, for example, we could plug it into here. So this equation says x plus 2y equals 3. Well, now we know that x is 2. Like we just got done finding that. So 2 plus 2y equals 3. And now you can like subtract the 2 over to the other side and then divide by 2 and know what y is, okay? But let's say there's not already opposites. Okay? What if the system is not perfectly ready to add the equations together? Well, you're going to alter one or both of the equations so that one of the variables are opposites. Now, the way we do that is by multiplying something to one or both of the equations, right? And this is where you just got to think ahead, and you have to kind of freestyle it, you know what I mean? Because you can choose the x's, you can choose the y's. Sometimes one of them is easier than the other and less work anyway. So in this example, I see that making the x's into opposites, I'd have to change both of them. Unless I want to go with fractions, which no. So I noticed that I can change this y to the opposite of negative 2y by multiplying it by 2, right? If I multiply this by 2, then the y's will be opposites. You know what I mean? And so but remember, you have to multiply the entire equation by 2. So this first equation changes into 4x plus 2y equals 10. The second equation didn't need to change for me to have opposites among the x's or the y's. So now that the y's are opposites, I can now pull the trigger on adding the equations together. Those cancel out just like I planned. 4x plus 3x is 7x. 10 plus a negative 3 is positive 7, and so x equals 1. And then you would solve for y the same way you always do. All right? Now, let's see here, people. Multiplying polynomials. So like number 9, okay, number 9, just remember that this is a problem where you're taking the distributive property to the next level. So these are like two terms in a grouping multiplied to another group of two terms in another grouping. So just remember, like, you don't just have to distribute the minus 3, you also have to distribute the x. Okay? A lot of teachers call this FOIL, because with all the distributing, you're doing the firsts, that's the f in FOIL, to get 6x squared. Then you're doing the outers, the outside ones, which is the O in FOIL. So x times negative 2 is negative 2x. And then you're doing the inners, which is the I in FOIL. So negative 3 times 6x is negative 18x. And then you're doing the last term in each bubble. That's the L in FOIL. And so you're doing negative 2 times, negative 3, getting ahead of myself, negative 3 times negative 2 to get positive 6. And now you just have to see that you can clean this up a little bit because these two terms are alike. So 6x squared comes on down, and then negative 2x minus 18x, that's negative 20x when you combine those two terms, and the plus 6 comes on down. So that's number 9. So for now, question number 10 is based on factoring. Alrighty? So take a quick sip of water. So trying to focus on how number 10 is worded, okay? The reason that, let me find a, I'm trying to find, yeah, let's go with number 10. It's funny how they use every variable in the alphabet. B, N, N, M, N, B. Well, I guess they're not using a whole lot of X, but anyway. So number 10, the reason that this can be factored, which it can be unfoiled, you know, like the reason you can figure out what two bubbles multiply together to make this is because, ready? There are two numbers that multiply to get positive 18, but they also add up to positive 11. Okay, so this would unfoil into, you know, obviously the bubbles would start off with A and A, or X and X, or whatever. But the two numbers that multiply to make 18, but they also add up to positive 11, are positive 2 and positive 9. Okay? So if this was not even here, like if it was a blank, like in number 10, you could say, well, we could make this number be an 11 because 9 plus 2. But since we can also multiply 3 and 6, like 3 and 6, if this was left open, then the bubbles could be plus 3 and plus 6, which means this could also be a 9. So two examples, it's not all the answers, but two of the answers, for this, it says, well, this blank could be 11, obviously, or it could be 9. If this was a 9, then we could have also factored it with 3 and 6. So that's kind of where number 10 is coming from. Now, if you are doing a slightly tougher example, potentially negative 24. So let's just kind of cover this up. You know what I mean? What could that be for this to be able to be factored? Well, I mean, numbers that multiply to make negative 24, for example, would be like negative 2 and positive 12. But also positive 2 and negative 12, right? That's another different answer. And so when you add these numbers together, here you get positive 10, here you get negative 10. So if this was like a positive 10, we'd be good to go. So there's an answer. If this number here was a negative 10, we'd also be good to go. But there's obviously more ways to get this negative 24. There's like positive 6 and negative 4. There's also negative 6 and positive 4. And so that's why we actually have here a plus 2, because of right here. Positive 6 and negative 4 make plus 2. But if this would have been a negative 2, we still could have factored it. You know what I mean? Anyway, I think this video is long enough. If you're still struggling, then feel free to reach out. But that does it.